Thank you everyone for being here, for attending DevFest, and for coming to my talk. I hope you've enjoyed the event so far. I know I enjoyed quite a few of the talks already, and I'm going to get started right away. So we're going to be talking about something called Deno today, but before we get there, let me introduce myself. For those of you who don't know me, my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And you can find me on Twitter, my Twitter handle over there, and my website as well, if you want to check out some of the other projects I work on and the things I build in my spare time. I work for a company called Quora. I'm a co-organizer of the Josie.js meetup group. We meet on the second last Thursday of the month, or online at the moment. So if you're interested in anything JavaScript related, join us. Come have a look at what we talk about. I'm also a Microsoft MVP, and I was given the MVP award because of my contributions to the South African dev community, mostly in terms of IoT, because I have this weird thing where I like taking IoT and JavaScript to relatively unreliable technologies and putting them together. I started off with hacking a Star Wars robot with JavaScript, and since then I have done things like built wine buttons, garage door automators, lightsabers, and a few others. Unfortunately, this talk does not have any things in it. I'm sorry about that, but I promise it will still be an exciting talk. Sorry about that, just getting my notes. All right, so first we're going to start with a little bit of a history lesson in JavaScript. A lot of the facts that I'm going to mention come from a talk called The Birth and Death of JavaScript by Gary Bernhardt. And whether you love or hate JavaScript, because I found that there's two types of people, those who love it and those who hate it, you should definitely give this talk a watch, because it's a very, very good talk. But I'm going to take you back to 1994. In 1994, the first ever graphical user interface browser that was accessible to everyone, not just tech people, was released. Later, that company was called Netscape, and they believed that at that time, the web lacked imagination. Everything on the web was static. So they, together with Brendan Eich, created JavaScript. And in 1995, Netscape Navigator 2 was released with JavaScript in it. Although the story goes that the name was officially LiveScript, it was renamed to JavaScript a few months later because of the popularity of Java at the time. Java was the hot new language, and everyone was using it, so they wanted to ride on that bandwagon. Although, as we all know, Java is to JavaScript as car is to carpet. The other story tells us that JavaScript was built in 10 days. And as you may have heard before, it really shows. But despite all of these things, and despite many people disliking JavaScript, it quickly became the standard for creating websites and running on the web. And people started asking the question, where else can we use this language? It wasn't until 2009 that Brian Dahl actually answered that question for us by creating Node.js. Node.js was not the first server-side JavaScript runtime, but it is the most popular. Together with NPM, Node's package manager, it became very popular very quickly and started being used by many people because it made server-side development accessible to JavaScript developers. Its event-driven IO and V8 engine made it nice to use. And to this day, many companies, big and small, still use Node.js as their backend, despite all of the many doubts in the language. JavaScript became, in the early 2010s, became the most used programming language in the world. But then in 2018, Ryan Dahl did a talk called The 10 Things I Regret About JavaScript. And in it, he mentioned a lot of the problems, the 10 things I regret about Node.js, sorry. And in it, he mentioned a lot of the problems, like the lack of promises, the fact that Node does not follow web browser standards, the lack of security, the use of the Node modules folder, and things like the fact that it was based on GIP, which was a necessity at the time because Node.js was built in C. A lot of these problems were very difficult to address because of the fact that it would break backwards compatibility with many of the systems that were already using it. Then he started talking about a new idea, an idea that would build on all of the good parts of Node and address some of these problems that we had noticed over the years. He called it Deno or Deno. I'm not sure how you pronounce it. I pronounce it Deno. And at the time, it was only 1 month old. It was still a prototype, and it was actually built in Golang. Then in May 2020, so this year, version 1.0 of Deno was released. It's a secure runtime for both JavaScript and TypeScript, and it still uses the V8 engine. However, it is built in Rust rather than in C. So let's talk about some of the advantages of Deno. And I'm going to talk about a lot of these, comparing them to Node, because that's what it's comparable to. The first one, and probably one of the more important ones, is that it's secure by default. Unlike Node, when you create a Node application, it has access to everything straight away. It has access to the network, it has access to your file system, everything on your computer. However, with Deno, you do have to specify what access you're giving to every program. So you have to explicitly say that you're giving it access to the internet. And I'll show you an example of that a little bit later. It supports TypeScript out of the box. And now this part here, I know a lot of people don't like TypeScript, a lot of people do, but the fact that it's available is really nice. It means that you don't have to look for another third-party library to install in order to be able to support TypeScript. It ships as a single executable. This one is really nice because you can just install Deno and run a Deno upgrade whenever you need, whenever you need to update to the latest version. So it's only one single file. It comes with a standards library. So the standards library is a set of modules which are guaranteed to work with Deno. And these modules provide us with basic things so that we don't have to look for external libraries in order to do basic stuff in our programs. It follows the web browser standards. So this was one of the disadvantages of Node. Because a lot of Node was made before a lot of these things were standards, there was no way to follow those standards. So Deno follows exactly those things. And you'll see an example of some of that later. But things like the fetch API, WebSockets, promises, all of those are exactly the same as you would write them in a web application. And it has a bunch of built-in tooling, which is quite nice. Things like formatting, linting, testing, which I'll talk a bit more about a little bit later, but they're built in, which means that, again, you don't have to look for an external third-party library to accomplish these things. Sorry. Just need a sip of water. Now, based on these advantages and comparing it to Node, you would think that Deno is the answer to all of your questions. But it wouldn't be fair if I did this talk without telling you what the bad parts are. So let's talk about some of the disadvantages. Firstly, it's not compatible with Node or NPM in any way, which means that if you decide to go with Deno, there is nothing you can reuse from what you have already in a Node program. You would have to do an entire rewrite from scratch. The TypeScript compiler is really, really slow. And this one is quite an important one. So one of the big advantages of Deno is that it supports TypeScript by default. And a lot of people want to use TypeScript with it. But this compiler is very slow and very unoptimized. They've mentioned this in their blog post that they're working on fixing it. But in the meantime, if you want to use TypeScript, you have to accept that it will be slow. The plugins and extensions are still in development. So there are a whole range of third-party libraries and extra plugins and extensions that were developed by the Deno team as well as open source ones, but they are still in development. So whenever you run one of these, you have to run them with an unstable flag to acknowledge the fact that you know that this is something that's unstable and could have vulnerabilities inside it. And there are a lot of permission flags. You'll see when we run some of our demos in a moment that your startup command becomes very long very quickly because you have to keep adding a whole range of different permission flags. So with that, let's get onto a demo. So I can show you some code. In order to install Deno, you just run brew install Deno. I've already done this, and so I'm going to skip it so we don't have to rely on my internet. And here we have this empty JavaScript file. The other stuff in here is just a README for my notes and some data, which I'm going to talk about a little bit later. But let's start with the simplest of things, a hello world. Console log, hello DevFest. And to run this program, we just go Deno run. And we have hello DevFest. Console log works. Great. We can do our standard debugging like most JavaScript developers. We can also do things like functions. And let's call our function hello. Put in a name. And we can go return hello name. Exclamation mark. Save that function, not functions. And then we can call our function from over here. Save that, and we run it, and we expect to get the exact same result, which is great. We can also put our function in a completely separate file. So if we had another JavaScript file over here called hello.js, and we export our function, we can import it over here. Hello. Importantly in Deno, which is something that's also a difference from Node, is you always have to provide the extension in your import statements. That's, again, closer to the web than it is to Node itself. In Node, you don't have to provide those. And we want to import our hello function over there. And we still have the exact same result. One of the other cool things which is supported is, again, similar to browser standards. If we put a %C over there, and we can then add in things like background color, purple, why not? Purple, and color white. Oops, that's not what's gonna work. That's not where that goes. It goes over here. Sorry about that. Bracket in the wrong place. There we go. There we go. We have our purple text. So you can store your console logs in Deno. And that's cool. I mean, you have console logs. We have that everywhere, right? So that's probably what you're thinking right now. So let me show you something a little bit cooler. As I said earlier, Deno supports the fetch API. So we can do things like this. response equals fetch, and let's just have a URL over there. But now you're thinking, fetch API is a promise. Do we add a .then over there? No, we don't need to, because Deno supports top-level awaits. So we can do things like this. Await response.json, and then we do console.log data. Oh no, we have an error. Why do we have an error? Well, if you remember correctly, I told you that Deno is secure by default, which means that our program is not allowed to access the internet unless we tell it it's allowed to access the internet. So what we'd have to do in order to do that is add a allow net flag. And you can even specify what it's allowed to access. So in this case, we're just going to access this website. And then we give it main.js. And there we have it. Our data has been fetched from the internet. That's pretty cool. And top-level awaits are something I'm really excited about. They're very useful. Okay, and then we can do things like build actual programs, things that we can use. One of the things we most commonly build is HTTP servers. And there's a way to do that. First thing we're going to do in order to do that is import the standard library from Deno for an HTTP server. And then we can do things like this. Const server, and we create a new server by serving our hostname of 0.0.0.0 and giving it a port 8080. Once we have our server, we can just log here that our server has started. So server started. And then we can listen for requests. We do that by creating a for loop, which will wait for a request from the server. And then it will do something, like, for example, our earlier fetch code. Response. Ooh. Oh, wait. Oh, no caps. No caps lock. I'm not shouting, I promise. Fetch from the picture URL. And then we have our data, which will be from the response.json. And then we can actually respond to the request. We do that by saying request.respond. Status 200, because we've successfully fetched, and body will be your picture. And data.message. All right. That's all we need to create an HTTP server. And now if we run this again, we are only allowing it access to .co website, but we're creating a new server which has access to localhost, which means that we can now either add localhost over here or remove this completely and say that it's allowed access to the entire internet. And if we go to something like Postman, let's just zoom in once over there and hit a send, you can see that we get our response body over there. And this is great. This is a built-in way, with Deno standard way, to create a server. But you can also use third-party libraries, which is really cool. And you can go back to things you already know from Node. So one of the third-party libraries that I'd like to show you today is called Oak. The Oak library, so the X over here means that this is a third-party library. The Oak library is Deno's equivalent of Koa. So it looks almost identical to Koa. If you've ever used Koa in Node, it looks almost identical. And you'll see that now. So let's call Oak setup. And we create a new router, a new application, and set our port to 8080. Then we can create our first route. Our first route will be on over there, so default route, and it's going to do something. It's going to take in a context and return a function. That function will be some sort of response. The status will be 200, and the body will be hello from Oak. And now we need to actually start up our application. To do that, we first need to add the routes that we've created and allow the methods that we are using, and then we listen on the port. So let's just restart our server over here. And if we call send, we have our response with a status of 200, which is great news. So let's actually build something useful. Let's build a to-do application. I'm going to create a folder over here and call it controllers. This is where our controllers are going to go. And our first controller is going to get a list of to-do items. So I'm going to call it get-to-dos.js. Now, this is one of the pitfalls of dealing with something that is still on version 1. I wanted to do this demo using a Mongo connection, but the only Mongo library I could find was a third-party library, and it doesn't work with Deno 1.4, which was released quite recently. So the third-party library hasn't been updated, and I didn't want to downgrade my Deno, so I decided to just do this a different way by using a JSON file. So my JSON file has some to-dos inside it, and I'm going to create another file over here called alltodos.js. Alltodos.js is going to have a file path, which will be to that JSON file, todos.json, and it's going to get the data out. So to get the data out, we're going to use a built-in Deno function called read text file, and then pass that to JSON because we know that it's JSON data. Then in here, we can import that function from alltodos.js. Don't forget the JS. And the function's name was called alltodos. Then our function will look like this. It will be called get-to-dos. It will have a context. It will have a status of 200 and a body of data, which we're going to get in a moment. And on error, we're going to log the error and return a status of 500 with the error message. So we need to define our data. And that will just be await all to-dos, like that. Now we need to replace our function in the main folder for our get root to be that get to-dos. And our import is a .js at the end. All right. Now, before we can run this, we need to add one more permission flag. We're now reading data from the file system. So we need to allow read. Now, if we run that, we have our to-dos. Okay, then next one. We have a get, now we need a post. So let's have an add to-do file. In our all to-dos, I'm going to add one more function called save, which will also use a built-in Deno function called write text file. And it will take the same file path and just write the JSON string. In our add to do, we need an import again from all to dos, JS, and that will be, we want all to dos as well as save all to dos. Our function in here will look kind of similar to the get one. It will be called add to do. It will return a 201 with a body of created. And the error section will be exactly the same. Then inside our try block, we need to read the body. So in a post method, we get a body on our request, and we read that by calling request.body and then body.value. And our object here will just be a title. Then we want to create an ID. So we're just counting from 1. You can use something like an object ID or something to that effect over here for your unique identifiers. And then we create a new to-do. New to-do has an ID, a title, completed set to false, and a date created set to right now. Then the last thing we need to do is save our to-do. I'm saying the word to-do a lot. So we're going to call save all to-dos, and we're going to pass it the data we already had, as well as our new to-do. There's our function. Now let's implement it in our main router. So this will be a post, also to the default path, and it will call that function. It automatically imported it for me, which is great. Now, we need one more flag. Remember what I said about too many flags? Yeah, here, this is where it's getting up to the point where it's too many. We also need to allow write. Okay, so we can still call our get to do, still have 3 to dos, and if we go and define our body with a title, mark a to do as completed, and we change this method to a post, we send that in, we have a created, so let's change that back to get, and we have our 4th to do over here. Marked a to do as completed. Awesome. So now let's actually try mark a to do as completed, because we need to mark number 3 and number 4 as completed. We've done those already. So we're going to have a new file called update to do. And in the interest of speed, because this is going to be very similar, I'm just going to put these back and just talk through them, because we may run out of time. So the update to do is very similar to the add. The difference is we're now getting the ID out of the context parameters. Again, if you've dealt with Koa or even Express, you'll be familiar with this kind of syntax. And then we find out to do. If it's not found, we return a 404. If it is found, we want to update the data and save those to-dos. The delete, similarly, gets the ID first, checks to find the correct to-do, otherwise returns a 404, and then calls a save. That's it. Now, in our main.js, we need to add those 2 methods. So the update would be a put. It would be /ID, and we'll call update to do. And lastly, a delete. Oops. Delete, which will also be to /ID, and it will call delete. Great. All of our imports are there. They all have the .js extension. We can stop this, run it again, and make sure everything is working. So for our update, we're calling a put with the ID of 3 because we want to update number 3 to true. So we call that, and if we call a get again, we should have completed set to true. And we can also delete. So number 4 was deleted. If we call that, number 4 is now gone. And there is your simple to-do application built in Deno using Oak. One of the other things I wanted to show you is how you can debug Deno. There is an extension for Visual Studio Code for debugging Deno, but that extension is not very developed yet. It's still very new. It's still in progress of being created. So I haven't actually got it to work for debugging purposes. So the other way you can debug, though, is inside the Chrome DevTools. So over here, if we add a --inspect -b.k, and we open up Google Chrome to Chrome /inspect, we can see our target over there. Zoom in a little. Deno main, there's our file loading. And if we click inspect, it opens up in Google Chrome's DevTools and is stopped on the first line. You can hit play there, and in our files, zoom in a bit, we have all of our files. And if we go to get controllers, I already have a breakpoint over there. So if we go back here and say send on the get, we have our breakpoint hit. And now you can debug through everything and see what's happening. It's pretty cool. Makes it work very similarly to if you're actually developing for web. So you don't need to learn too many new things. Okay, now we've seen our demo. Let's talk a little bit more about some of the things we saw. The first one I want to talk about is modules. And this one is quite important because we all know that joke about the Node, when you run npm install Node, you download the entire internet and your Node modules folder is always the biggest thing in the world. And modules in Deno work quite differently to Node. As we saw, we import them directly using ES6 module syntax from a URL or a file path. The problem with that, I'm going to talk about in a moment, but all of the modules are immutable and cacheable, which is nice because you have to use a specific version of the module and it's cached locally. So you saw that every time I restarted, I didn't have to go and re-download those things because I have them downloaded. If I wanted to re-download them, I would have to add another flag, surprise, surprise, called reload. And that you can see is re-downloading all of the modules that we used inside our file. Then how do we manage these modules? Well, one of the recommended things is that you always pin to a version. So in our instance over here, we are just using Oak. We're not saying what version of Oak we're using. This is not the recommended way of doing it. The recommended way is that you pin to a specific version. That way, when it's updated, you don't get random breaking changes that you don't know about. And how do we make sure that all of these modules are in the same place? Well, currently they recommend that you do that with a dependency file. So have all of your imports in one file and export them from there so that the rest of your program can do this. The problem with this is that there is no way to do vulnerability checking on those modules. So whenever you run with something like that, you have to use for a lot of the modules that you use, you would have to use an unstable flag. Otherwise, they might not work. And that could be a problem for production level systems. Then testing. Testing in Deno is pretty cool, actually. There is a Deno test. They're still working on the parts where you can mock things, but just running Deno tests, you can do things like coverage as of Deno 1.4, and you can do assertions. So any module that's imported into your test file will get its coverage checked when you run with the coverage flag. And one of the advantages I mentioned earlier is all of the tools that are available. Things like install. So if you have a executable code, you can install it locally. So we were accessing modules directly from the web. You can install them locally and access them from there. Format. So Deno format will run a code formatter on your code. Bundle is for when you want to create your file into one bundle so you can deploy it. Doc will create documentation for your code. It's pretty cool. It creates JS docs. You can specify that they must be in JSON. It's quite useful. Info is a dependency inspector. So if we run Deno info on our set of code, we can see where all of our dependencies are. And if we run Deno info on main.js, we can see all of the things that it uses, including all of the dependencies, which is cool, and how big they are. Lint is for linting. It uses TSLint or ESLint, whichever language you're using, and it's the standard way of linting files, I believe. So, in conclusion, I know I went through that quite quickly, but I think I am pretty much out of time. So let's wrap up. Is Deno just Node, but alphabetically? Well, the answer to that question, I believe, is no, it's not. It's quite different. It's built on the good parts of Node, definitely. It takes the good parts of Node into itself. But there are a lot of new things in there that you can use. And as far as it being ready yet for production, in my opinion, it's not. It's a great new tool and it's going in the right direction. But for right now, I probably would not recommend it for a big production system. Anyway, that was a lot of speaking. Thank you very much for listening to me.